Hello there guys, in this lesson we will learn about the for loop, what it is and how to use it. So without further ado, let's start. Now for loop is very similar with other loops such as while and do while. It is used to perform a process several times. Now there are some differences when it comes to constructing a for loop, and we will look at those differences right away. So first we have the keyword for, then the condition there, and then the body of the loop. Right now it looks very similar with while and do while loop. The difference here is that inside the condition we declare the loop control variable, we give the condition here, like I is less than 10, and we also do the incrementation or decrementation or whatever. So everything we do it inside the brackets of the for loop. In the body of the for loop, then we just write what we want to perform, like for example cout a and line, semicolons at the end. We build it and run it, and as we see here, we get the output. Now, it's quite cleaner and it looks much better than when we had the while loop that we needed to first write the condition I is less than 10, and then we would need to write the same code here. But at the end of the code, we would need to increment I, and also we needed to declare I outside of the loop, like int I is equal to 0. So this is a little bit confusing, and when you got a lot of loops there, then everything might get messy. Whereas with for loop, everything is much cleaner. We've got everything here in the loop where we also have the loop condition. Now, how the for loop works is a little bit trickier. Let us say we have run a few things and then we come here to the for loop. We first initialize our loop control variable, in this case I, and in this case we give it the value 0. Then we check if I is less than 10. If that's the case, we perform whatever it is in the body of the for loop. We then come here at the end of the body, and then we jump at the incrementation part. Let's say this incrementation can be incrementation or decrementation or even multiplication, but in this example, we have incrementation by 1. So we jump here, we increment by 1, and then we check if the condition of the loop is still true. Then we go back to the body. We go back to the body if the condition is true. If it is not true, then we just jump out of the loop here. But if it is true, we jump back to the body and perform the body again. Caution that we do not initialize again I with 0. This happens only the first time. The first time that when we enter the loop, then we initialize I with 0 and that's it. Then we just perform the incrementation and the checking for the condition. We do the same process, we perform whatever is inside the body of the for loop, we reach the end of the for loop, we jump back, we increment by 1, then we check if the condition is still true. If it is, we keep doing this process. If it is not, we just get out of the for loop. So this is basically it for the for loop. Pretty straightforward. Now, a very useful place where we use for loops is when we are working with arrays. And we declare just an array of integers with 3 integers. This can be 4, 3, and 2. Now I want to print the elements inside this array. So I could write something like this. Since we've got only 3 elements, I needs to be less than 3, and I will explain why we use I less than 3 and not I less than or equal to 3. So we first build it. Okay, we have forgotten and the L there. As we see here, we've got 4, 3, 2, the elements inside the array. Now, if we were to actually print the I, just the I that we are iterating through, as we see here, we get the values 0, 1, and 2. So as we said earlier, in order to access the elements of an array, we know that they start from 0 until n minus 1. So in this case, we will need to go from 0 until 2 and not until 3. That is why we use the condition I less than 3. So we can make it a little bit more obvious, the code, so you can make the difference here. What are we doing here? Let's write something like this. array. We build it and run it. And as we see here, at index 0, so when I is 0, we access the first element of the array. At index 1, we access the second element of the array, which is 3. And at index 2, we access the third element of the array. So here are the values of I. Here are the elements in the array. This is very useful. We will use for loops and arrays very often. There's also another way how we can write, how we can print the elements of an array. And this is a little bit confusing. What I showed here is the standard for loop. Okay, this is the standard, and we will use it a lot. But there's also another version of the for loop, which is something like this. If we build an array, what we see here, we get the elements of the array. Okay, this can be called an iterator. We just iterate through the elements of the array. As we see here, 4, 3, 2 is the same output as before. The only difference here is that everything looks much cleaner. And where we use this is, for example, we have an array, but we do not know its size. It can be 3, it can be 14. We don't know the size, just we don't know the size. But we want still to iterate through all of its elements. So we can use this form of a for loop to iterate through all of its elements. In this case, what we would get would be just the 3 first elements, 4, 3, and 2, and then all others are initialized with value 0. Something very important here that you should not forget is that these semicolons here are very important. So if I let me just do something like this. If I were to, for example, delete one of these arguments here, then the compiler wouldn't give us any warning. Even if I were to delete the second one, still the compiler said, okay, everything is okay here, despite the fact that we know that this thing would just end up messing our program, but still the compiler doesn't give us any warning. If we were, however, to delete, let's just go back, if we were to delete one of these semicolons, even if we delete the argument, so we say we just don't have any argument there, we don't do incrementation, we have done incrementation right here, so we don't need to do it up there. Well, that's not how the compiler works. It would give us an error. If we the compiler just doesn't allow you to delete these semicolons. If we would just add the semicolon there, then everything would be alright here. And in fact, if we were to print it, then we would actually get the correct output, because I was wondering why didn't we get the elements of the array, but we're just printing I here. So we actually get the correct output. And even if we just give a for loop like this, still for the compiler, everything is alright here. We haven't declared I there, but still, just for an example, everything here for the compiler is alright. No warning here, because the most important thing here is that we keep the structure of the for loop intact. Now let me just give you an example of another, not just iteration by one, but decrementation in this case. Let us say I is equal to 0. I has to be bigger than minus 10. I minus minus. We're to print this I here. And then we build it and run it. And as we see here, we get all the negative values from 0 to minus 9. We can also do the same thing, but this time with multiplication. I is equal to I multiplied by minus 2. And as we see here, we get 1, minus 2, 4, minus 8, 16. Now, some of you might ask, why do we have positive numbers and negative numbers? And then again positive, then again negative, and then again positive? Because what we have here is that if you do the calculation here, I will sometimes be negative, because the first time that we do this, I times minus 2 would be minus 2. But then when we would do this again, I, which is minus 2 times minus 2 would be 4. And that is why we would actually get a positive value. But still, this is just a way. I just want to show you that we can also perform multiplication or division here. Let us give just I value 10 here. I has to be bigger than 0. And I is equal to I divided by 2. In this case, we would get the values like 10, 5, 2, and 1. Anything below the integer 0 would stop the loop here. And this is basically it for loop, guys. Very important structure, we will use it a lot. It's very efficient, so I hope you learned something today. See you next time.